This is the Yukon ECE 2001 final project, creating a laser transmitter and receiver that can take an audio signal that has been input through either an aux cord or a microphone, can transmit it via laser to a receiver using a photodiode that can then repeat that audio signal through a speaker. In addition to being able to simply transmit and receive an audio signal, there were three conditions that were associated with this project, the first of which was the transmitting range. The circuit was to be able to transmit the audio signal at least 15 feet away using the laser. The second condition was that the sound produced by the speaker had to be at least 70 decibels at a range 2 feet away from the circuit where the signal was received. The third and final objective of the circuit was to include a volume control modifier. This component allows you to change the volume that is output from the speaker without touching your audio input device.
This is the transmitter portion of our circuit. As you can see, there is a microphone right here that you are able to speak into to produce an audio signal. There is also a resistor here. This is where the aux cord can be plugged into so that you can receive an auxiliary signal. The capacitors and resistors allow us to alter the signal that is being output through the laser transmitter so that we could better broadcast it. The signal passes through this op-amp first, and the output goes through this capacitor, which then ends at the positive input to the laser transmitter. The negative input is just connected to ground, and as you can see, when powered, you are able to produce both a laser as well as a flashlight from the laser transmitter. This is the receiving portion of the circuit. As you can see, there is a photodiode right here. When the laser is shined on this, or the light, the circuit is able to receive that signal that was output through the laser transmitter and is able to play that through the speaker, which receives its output from the second op-amp shown here. Lastly, this potentiometer, which is connected to the receiver circuit's op-amp, is what allows us to control the volume output from our speaker in the circuit. By simply varying the resistance in the potentiometer, the sound output through the speaker can be changed so that the signal can come out either louder or quieter, depending on what is required. The circuit itself is powered by two 9-volt DC batteries. As you can see, the first battery has its positive terminal plugged into the positive row and its negative plugged into the negative row. The second battery has its positive terminal plugged into the negative row, making this negative row ground, while its negative goes into this negative row, producing a negative 9 volts compared to the positive row, which produces a positive 9 volts.
The circuit demonstrated in this video was able to meet all three requirements of the project. The potentiometer that was shown was able to limit the sound that was output through the speaker, changing the volume of that received signal. The transmitter itself, you were able to see functioning and was able to transmit its laser over the 15 feet limit that was required for the project. Lastly, the sound measured at 2 feet away from the circuit as it received its signal was around 74 decibels, meeting the third requirement for the circuit.